Hello, good evening. Today I will be discussing traversing insertion sort. So, what is an insertion sort? Insertion sort is a sorting algorithm that places an unsorted element at its suitable place in each iteration. Insertion sort works similarly as we sort cards in our hand in a card game. We assume that the first card is already sorted then. We select an unsorted card. If the unsorted card is greater than the card in hand, it is placed on the right. Otherwise, it is placed to the left. In the same way, other unsorted cards are taken and put at the right place. A similar approach is used by the insertion sort. How insertion sorts works. So if you look at this initial array, 9, 5, 1, 4, and 3, how do we sort this following array? The first element in the array is used to be sorted, and it is assumed that is already sorted, just like in our card game. Take the second element and store it in a separate, and it is called key. Compare key with the first element. If the first element is greater than key, then key is placed in front of the first element, just like this in step number 1. If you look at 9 and 5 and they are compared, since 5 is less than 9, 9 will be moved to its right and 5 will be placed in front of 9. So, therefore, if the first element is greater than the key, then key is placed in front of the first element. That is the step 1 in insertion sort. Now, the first two elements are already sorted, the 9 and the 5. We will then take the third element and compare it with the elements on the left of it. Place it just behind the element smaller than it. If there is no element smaller than it, then place at the beginning of the array. So if you look at the illustration, we compare 1 with 9 and 5. Since 9 is greater than 1, we place 1 ahead of 9. Then we compare again 5 and 1. Since 1 is less than 5, we put 1 ahead of 5 and 9. Then these 3, 1, 5, and 9 are already sorted, which left us 4 and 3 as the unsorted ones. Therefore, since 1 is the smallest of the 3, you place 1 at the beginning. Similarly, place every unsorted element at the correct position. So if you look at number 4, in step 3, we compare 9 and 4. Since 9 is greater than 4, we place 4 in front of 9. And then we compare 5 and 4. Since 5 is greater than 4, we place 4 ahead of 5. Then we put 5 behind 4, and we put 4 behind 1. Since 1 is the least of them. So we are only left with number 3 with this array. So we compare 3 to the left, which is 9. Since 9 is greater than 3, we place 9 ahead or behind 3. Then we compare 9 and 5. Since 5 is less than 9, we just place 5 ahead of 9. Then we compare 5 with 3. Since 3 is less than 5, we put 3 ahead of 5. Then we compare 4 and 3. Since 3 is lesser than 4, we place 3 behind 1 and the array is sorted. So this is the insertion sort algorithm. So we declare the insertion sort as an array. Then we mark the first element as sorted. For each unsorted element x, extract the element x. For j, this is the last sorted index down to 0. If the current element j is less than x, move the sorted element to the right by 1. Break the loop and insert x here, and then end insertion sort. These are the applications of insertion sort. The insertion sort is used when, number 1, the array has a small number of elements, and then there are only a few elements left to be sorted. To compare insertion sort and the selection sort, the insertion sort is quite straightforward. You just insert all the elements that is lesser than the elements to the right of the bigger element. In the selection sort, we use two subarrays, the sorted subarray and the unsorted subarray. We just swap the first smallest number to the first element of the unsorted list, and you do the same and repeat the same until you get an assorted array. So that would be all. Thank you and have a good day.